All right, here is part 2 of the proof of the derivative of the sine function. Picking up kind of where we left off, this is a little bit of an aside. We have to show that the limit as x approaches 0 of sine of x over x equals 1. And that will, going back to the part 1, that'll show that the final derivative of sine of x is cosine of x. So in order to do that, we have here a unit circle. And I've drawn an angle. We have an angle with a measure of x in there. And we have some relationships going on in there. The main thing we need to see here at the start is there's 3 regions. Okay, region 1, region 2, and region 3. Region 1 is red. Region 2 is the turquoise, but region 2, as it says down here, includes region 1. Okay, and region 3 includes region 2. Region 3 is the green plus all of region 2. Okay, what we want to see is a relationship, and it's right here that region 1 is the smallest, region 2 is the middle, and region 3 is the biggest. In order to show that this is true, we're going to use one of my favorite pieces of software, Geometers Sketchpad. So I'm going to switch windows here to Geometers Sketchpad. Okay, here we have Sketchpad, and we have a circle drawn with an angle inside, and we have the same regions sort of drawn here. We have region 1, region 2, which is this region plus region 1, and then region 3, which is that area right there, plus region 2, and of course, therefore, region 1 as well. We want to see what this helps us to do with Geometers Sketchpad is I can grab these points and move them all around, and we can see that always anywhere from 0 to 90 degrees, right, or pi over 2 radians, that these relationships are true. And as the angle gets bigger, of course, the relationship is obvious. Region 1 here is very small. Region 2 is bigger, even if you don't include region 1, but of course you do. And then region 3 is gargantuan, and the area goes to infinity as the angle increases. And this also works in negative. If we go down here for negative degrees, negative angle measure, negative radians, it works. The question is as it gets small. And it gets a little bit harder to see, but still, and region 1 looks big here, but of course region 2 is this little slice in there, but we're adding to it region 1 as well. So of course it's a little bit bigger. It's not by much, but it is a little bit bigger. And then region 3 is in here somewhere, is that little slice, plus region 2. So while it's not very much bigger, it is actually bigger. And you can see, and I can zoom in here a little bit by making my circle bigger, that this will always be true. As even as I zoom in, and it gets really, really small, there's always those extra little slivers. I'm adding one little sliver for region 2 and another sliver for region 3. We can see this get bigger and bigger. And I'm not changing the angle measure. You'll see as I zoom in, I'm not changing any angle measures or anything. And it gets harder to tell, but it's always going to be that case. There's always going to be those little slivers. Okay, now what happens the one time this changes is that as I go to 0, the area of all 3 regions is, of course, 0. So it's possible that the regions can be equal. But if they're not equal, then region 1 is the smallest, region 2 is the middle region, and region 3 is the biggest. Okay? So we have an inequality, a 3-way inequality written out. We can calculate the area of these regions by using the unit circle and relationships within trigonometry. The sine of x is adjacent, right, which is this side right here, over the hypotenuse, which the hypotenuse is 1 because the radius of the unit circle is 1. So that means that this adjacent side right here is actually sine of x, because sine of x is that adjacent side over 1, which is just sine of x. So there you have it. And in the same way, this sorry, that was opposite. I meant opposite side all that time. Opposite side over hypotenuse. Cosine is adjacent over hypotenuse. So in the same way, this is cosine of x. And out here we have a a bigger triangle that forms region 3. And tangent is opposite over adjacent. And in this case, the adjacent side is 1. So we have those 3 trig functions that define some dimensions in there that allow us to write expressions for the areas. So area of region 1 is it's a triangle, so it's 1/2 base times height, and the base is cosine, the height is sine. Region 2 is a little trickier. It's a sector of a circle, which is like a pizza slice, and it's basically just a fraction of the circle. So you see the x over 2 pi, that is the fraction of the circle that it takes up. So x is the angle measure out of 2 pi, which is an entire circle. And then times pi, which really that's pi r squared, but r is just 1, so it's just pi. Okay? And then the third region is 1/2 times 1, which is the base, right? It's this base right here, times tangent for the height. The pi's cancel. Okay? There's also a 1/2 in all 3 of these. And so the 1/2s cancel. You just multiply all of them by 2. Okay, so we're left with cosine times sine. X is all that's left in the middle. And I'm going to write tangent as sine over cosine. Okay? We're no longer really representing the regions. We're just taking expressions that were equal to them, and now we're modifying it and changing it around. If we divide all 3 sides by sine, then the sines cancel out of these 2, and we get a sine under the middle. So that's where we get this step right here. Okay, and now we've almost got exactly what we're looking for. We have x over sine of x. We want sine of x over x. So all we have to do is take the reciprocal. We basically flip all of the fractions. So cosine becomes 1 over cosine. 1 over cosine does the opposite, goes to cosine. And of course, we get sine x over x in the middle. And don't forget, when we take the reciprocal of an inequality, the inequality signs change direction. Right? So we note that there. Now, if we take the limit of this whole thing as x approaches 0, as x approaches 0, cosine of x is 1. So 1 over 1 is 1. And as I just said, cosine of x as x approaches 0 is 1. And then the middle, we just write limit as x approaches 0. Well, now we have an expression where this we have an equation, rather an inequality, where this expression that we are examining is greater than or equal to and less than or equal to 1. And there's only one way for that to happen. This is called the Squeeze Theorem. It gets squeezed between these other 2 functions, and it turns out it is indeed equal to 1. So we'll go back to the part 1 of the proof just to see it. Go back to my previous page, and there's all the markups. But you can see here that we had the limit as x approaches 0, sine of x over x, which is the same form as this right here. And it turns out it's equal to 1. So 1 times cosine is cosine. And now we're done, right?